We are load testing this bridge and we are measuring how it deforms under that loading, and the data we get from this will help us quantify the actual capacity of that structure.
The bridges that built before 1950, these built like with the old techniques. So we need to figure out if these are working together or not by applying a truckload on the bridge, like in different positions, and then study the behavior of the bridge, of the slab and the girder each time.
For the Maine Department of Transportation, the potential savings are very large because they can take a bridge that currently is not able to be rated for the heavy semi-trucks and the heavy logging trucks that are in Maine, and allows them to, instead of replacing that bridge, simply use a more detailed analysis and get more capacity out of the bridge by taking into account factors that they weren't able to previously.
When we test these bridges and we demonstrate it's actually safe, we may be able to keep it in service for another 20 or 30 years without any modifications.
This project is really interesting for me because going forward I want to get into bridge engineering. It's really kind of cool that what I'm doing here, I'm helping to help the people of Maine.
The students come out here and they actually apply the knowledge they've learned in the classroom. They work with real engineers, they work with the DOTs, and they see how we can actually implement engineering in the field and make an impact on real infrastructure.
I very much think that the demand for bridge engineers and bridge engineering is going to be going up very high. A lot of bridges around the country and in the state are very old, older than the lifespan that they were designed for. And so there's a lot of bridges out there that need to be verified, say yes, these are okay to drive over, or no, these are not okay to drive over. We need to figure out a solution to make this work.
We're Maine State Flagship University. We're working with the Maine Department of Transportation. This information will also be spread out to consulting engineers in the state of Maine who work for the DOT, and it will make a huge difference potentially in the cost of our infrastructure. It will save everybody a lot of money, and it will inform the engineering profession in the state of Maine. That's our job.
There are huge opportunities in application of technology to infrastructure. We need people, we need engineers, we need people who are able to take that technology and apply it.
I think in the future we're going to see more and more of this. We're going to see structures that are self-monitoring, that can inform engineers about their condition on the fly. We're going to see new materials out here in the field. There are a lot of things coming down the pipeline.